My name is Chris Jackson. This is Sarvanan, my partner in crime here.
Yeah, my name is Sarvanan Paramasu. I work for TD Ameritrade as a software engineer.
Yep. So we are presenting Spring Cloud Gateway for stateless microservice authorization. We're going to talk a little bit about our journey. So we'll go ahead and get started. So as I said, our story, like pretty much most other firms, we are transitioning from, kind of the old school monolithic architecture to a more modern microservice architecture. We're trading we're trading the simplicity of a monolith that was slow and difficult to deploy to that distributed nature of, unfortunately, more complex microservices. And we're going to be talking a little bit about how we took on the security portion of that journey. So as I said, we want to implement a flexible, secure, and efficient authentication and authorization scheme for that microservice architecture. So everyone's probably pretty familiar with the terms. There have been a lot of talks about security already for the last 3 days. But just to hit the top points, authentication, making sure we know who a user is, and authorization, what do they have permissions or roles or grants to be able to do. So in a typical monolith, security was typically kind of a process. The user connected in, they provided their credentials, and security was kind of at the edge of that monolith. So we'd have a security module of some sort, we'd create a session ID and return that back to the user. But once they were inside our application, they were typically pretty free to do whatever. The app would route to different modules, but security was just kind of at the edge of it. The application would return that session ID back, and the user could just use that every time. That was typically a stateful application. So every time they came in, we already knew who the user was by that session ID, and they could go on their merry way. So microservice architecture can be a little bit different. We've got, our typical client apps. Maybe it's a mobile app or an external API. It could be a web application. And they need to connect to these dozens or hundreds of different microservices. We need to be able to secure each of those services. And it's a pretty complex system where we have lots of applications potentially connecting to lots of microservices. So should we have each of those microservices implement security from scratch for all those different clients are going to be calling them? Of course not. That doesn't make sense. That's a waste of time for us. So there's some different approaches we looked at to kind of tackle this problem. We'll go through them pretty quick here. A distributed session management. So that's a system of distributed nodes for maintaining that session. We could implement a sidecar proxy with each service. We could implement a shared library that all of those apps just pull in, or we can implement an API gateway. So to talk a little more in depth about that distributed session management, there's a few different approaches to that, a few different techniques. We could have a cluster of services and a load balancer in front of them to always route to the same session management server. So we'd mark a sticky flag, and then every time user 1 connects in, they go to server 1. That keeps their session information in memory or in a local cache of some kind. And then every time the user comes in, they hit that same server, and it's quick and easy. Unfortunately, that doesn't work great when that node goes down, or we have to restart it, or for some reason the load balancer loses that stickiness and it routes you to a different server. Well, I don't know who this user is. They've got to authenticate all over again. You could implement some sort of replication scheme between those different session management servers. But then you're kind of eating up the bandwidth, and then you add more complexity just on the authorization side, where you spend all your time trying to sync between those servers. Or we can have some sort of centralized session store, database, data store of some kind, where we're just kind of pushing the problem down. Each of those servers then will just go to the data store every time and validate that the user is who they say they are. But we're just kind of pushing the problem down, and then we can have some more challenges about how do we scale up that data store. And then in all these solutions, it's typically a stateful paradigm. So that doesn't really fit with what we were trying to move towards, to a stateless architecture. So there's also the option of a sidecar proxy. So typically this is implemented by having another service run in maybe the same container or the same VM as your microservice. And it handles some of those cross-cutting things that we don't want to deal with every time. Typically in a microservice, you want it to do one thing and do it very well, the single responsibility principle. We have a sidecar that can handle some of those non-core functionality things like logging and security that are very important. We need to have them, but we want to offload that onto another application. Unfortunately, as we've said with a lot of these things, that adds more complexity. So every time you deploy a new microservice, then you have to deploy a new sidecar as well to go with it. And just the management of all that can be a little daunting. So there's also the shared library of some kind. It's kind of a tried and true approach. And anyone who's been developing software for the last 20 years has used a shared library that says, oh, this is going to solve all your problems. We've written everything in there. You don't have to do the work. The library does it. And in a lot of cases, it works well. We do distribute our security so that we don't have a single point of failure anymore if it's handled in the library. And it still kind of contains those rules if we want to have that logic stored in the library. Unfortunately, that also sort of binds us in a little bit, and if we write that library in a particular language, then all of our other applications have to be using or can understand that language or run in the same JVM. Also, as everybody knows, anytime you have version 1.1 of a library, then you have to worry about how do I push that out to all my applications. So the solution we thought was pretty great and that what we went with was using an API gateway. So this typically runs at the edge level. It runs in front of all of the microservices, but we'll talk about some other use cases where it's not just that. Security for all our external applications is handled kind of at the edge layer in the gateway. And so any endpoint that we expose needs to go through the gateway first so that we can do all those cross-cutting concerns that we've talked about, security being the biggest. But then the microservices themselves can control the authorization of their content based on permissions that are passed to it. We're going to talk a little bit about identity propagation. And then those microservices can hopefully just focus on their core business logic, and some of the security can be handled, without them doing it. So as we've said, some of those cross-cutting things that we want to have centralized in the gateway. So every consumer who connects, we have that security implemented. We have a standard way of routing requests. We can implement rate limiting, any sort of metrics or analytics, or translation to even different protocols that the separate microservices might communicate with. So the gateway represents a really easy way to have at the edge level all of those non-functional requirements that you want to handle. So as you can probably guess by the title, we went with Spring Cloud Gateway. We thought that was a good solution for us. As a lot of other talks over the last 3 days have mentioned, it is a reactive project built on Spring Web Flux. It's a Spring Boot application that, so for our corporation, for our technology, that's something we were already very familiar with, and it was very easy for us to expand upon. And then we're also going to talk about a separate identity provider service that does implement some of those standard security protocols, OpenID Connect, OAuth 2. So that'll sort of offload some of the security requirements for it and leave the gateway to handle all those cross-cutting concerns. So some more advantages, some more things that we liked about Spring Cloud Gateway. Well, first of all, just the performance of it. We, ran it through their paces, compared it to some other products, and we found that the performance of it was very appealing. Low latency, good throughput, very small percentage of timeouts in our use cases. So it met the performance that we were looking for. We didn't want to implement something at the top level that was going to slow everything down. And also, because of our familiarity with Spring and because of how it's designed, we are able to write tests for our routes. And it sort of supports our agile journey to shifting more testing left and to be able to do some sort of test-driven development for that. So a little bit about the inner workings of Spring Cloud Gateway. It is like a lot of Spring projects where there's a series of filters and handlers in there to intercept and apply any logic you want. So typically a client will connect the first sort of module within the gateway is a series of rules or predicates where we can evaluate the request and see where it needs to route to. So what's the URI? What are some of the headers within the request? We can even inspect the body of it and have some complex or simple rules to route based on all those factors. So after we've chosen a route, the web handler module will evaluate a series of filters where, just like a lot of other Spring projects, we can modify the request in any way if we want. We can add or remove headers from the request. We can even change the body if we want. And then a series of global filters where we are implementing our security. And then the request will get forwarded down to that application service, microservice, wherever it is, wherever that route passes it on to. And on the way back, there's a series of post filters that we can additionally, do more logging, evaluate how long it took, any sort of metrics, but also modify the response object if we need to. If we need to strip any headers off of there that shouldn't go out the door, we can do that in the post filters. So to talk a little bit more about how we secure the gateway and how we can sort of propagate that token down the line to all of our services, I'll hand it over to Saravanan.
Thanks, Chris. So in most architectures, the user security propagation stops at the public-facing, internet-facing layer or at the API gateway itself, right? The services behind the gateway, app services and the data services, they might have an implementation for different type of security mechanism by passing a service account, or even some other services are not even protected, right? They're not secure. They might be relying on the network to protect the services, right? And also, in these cases, the microservices has to make additional calls to get the user authorization data to validate the authorization needs of the application. So in our architecture, so we will explain to you guys how we're going to propagate this user identity from the gateway, from the client through the gateway to your app services, and even beyond that to the data services. By propagating this user identity, we will also explain to you guys how we solve the problem of like stateless authorization, and then securing each request, each journey of the request through the components. From the implementation perspective, so with the Spring Cloud Gateway, we are the identity provider that works in conjunction and takes care of the authentication, authorization needs for the application. This identity provider will act as an authorization server, and then this will be deployed as a separate component that will be key to the architecture in providing and enabling the security for the application, right? Now let's dive deeper into the nitty-gritty details of how this user identity will look like in our flow, and then we'll give you guys an idea of how it solved the stateless authorization needs. So in this identity propagation, the key actor is a client. The client could be a user on a web application, or the client could be a mobile app, or client could be a third-party vendor integrated with your platform to pull in the API data from your applications, right? The first step for this propagation is the client has to pass in the credentials. It could be the user ID, password, and then could be a client ID secret that will send to the identity provider. And then the identity provider will in turn validate that all the credentials are good and in order. And then if it has challenge or show any multi-factor authentication, it will prompt all that. In turn, the identity provider will create a OAuth access token, which will be passed back to the client, right? This access token is will have a validity based on the session, and it will be in a way stored in the client, in either in the browser in the local store or in an application by itself. And then on any request from the browser or a client, we'll pass in this token, and that way the token is passed in the HTTP authorization header, and then when it reaches the gateway can inspect that. Gateway in turn now, using its predicates and routes, it will know from where the request comes through, and also it will know where it has to forward it to, right? But part of the gateway will also have a global auth filter, which will take care of communicating with the identity provider for their security needs, passing the incoming, that opaque access token, and then it will do a token exchange. So we'll talk about in detail in the next slide about token exchange, how it works. But in a short way, the token exchange will take care of calling the identity provider, and then the identity provider internally will again check for that incoming request if that has all the roles and permissions at a coarse grain level authorization, and then create a new token, which is a smarter token called JWT token that will have all the scope, and then based on who is the audience, target audience, whichever is the microservices, it will add in all the data, authorization data into the JWT token part of the claims itself. So now when the response comes from the IDP to the gateway will obtain the new JWT token and use that to forward to the app services. So with this now your app services will only know this JWT token, irrespective of what the incoming token was. And then now the app services will extract this token, understand all the scope of it, and then extract all the authorization data from it, validate the signature of the token. That's how this layer is secured. And then once it all checks out, then the app services will reach out to the underlying data domain services. And it could also obtain another token to secure this layer as well. And then once all this completes, the app service will get the response back for the scope it was requested, and then send it back to the client. And this is how the entire identity propagation works in our flow. And this is how we are securing each component in the request journey, right? While doing this, so we also spoke about a couple of things. The one main thing is we spoke about token exchange between the gateway and identity provider, right? So let's talk about it in a detailed way to see why we implemented with this token exchange pattern, and then how it helped us to follow a certain security model, right? The main thing about this token exchange is we are not reinventing the wheel. It's published by OAuth spec, and they are providing a way to create a security model to exchange token, and then also employ the delegation and impersonation of the token, right? By doing this, you're following exactly the contract provided by OAuth itself for the token exchange grant, and then you have all your grant type, client scope, all that built into that token request and response. So in our case, especially in our case now, the gateway, when it talks to the IDP, where it passed in an incoming token, and then it got a different token, which is a JWT token. In this case, the JWT token is impersonating the incoming token, and then it has all the rights of the incoming token within the limits of the security model, right? By doing this also, now you're also delegating the incoming token, it has delegated its actions to the new token, and whichever service is using it, it still is responsible for the actions taken with this token, and that's how all the auditing and security needs are met with following this token exchange functionality. So we also spoke about, we said that JWT token is a smart token, right? So let's understand that a bit. So most of you already know what is JWT token. It's a very open industry standard. It is the way you create stateless authentication authorization, especially for the authorization needs. The JWT token has three parts to it. You have the header, payload, and signature. Header tells you what is the algorithm you use to encode it. And then the payload is the main thing where you are creating the claims, custom claims, and then adding all the scope. That's where you're fitting in all your roles and authorization data. And then with this is where your microservices, when they get this JWT token, they will be able to just extract the data out of it and being really stateless, right? That's how we are creating the stateless authorization of it. And then you also adding the signature part to it to make sure it is signed with a private key by the identity provider, and then only the microservices who have this pair of public key will be able to decrypt and understand what is in the token, right? So also these 5 things you get out of using JWT token. So you're getting the fine-grained access control by keeping all your authorization data in that. It's very introspectable. You don't need any custom libraries. You don't need anything out of the box to code to get the JWT extraction. It's easily with very basic framework, you can easily extract the JWT, introspect that data, right? It's expiratable because part of the claims, you have an attribute for expiration. With this, You are creating this token with a shorter duration of expiration, and the token is invalid after that, and then the libraries can easily introspect that and then understand the expiration of it. And obviously, we spoke about stateless too, right? That's an advantage. Now, microservices doesn't have to deal with this, calling any services. It's stateless, and it's very, very secure. It's these two entities who are speaking with JWT, they are fully secured with this mechanism, right? So we spoke more about how we implemented it. We also want to take a moment and talk through what did we solve for, right? With implementing this pattern, what are the benefits that we achieved, and then which we feel that could be useful for whoever's listening to as well, right? So we spoke about stateless authorization. We didn't know how we implemented that, but what are the benefits of being stateless authorization, right? Now your services doesn't have to store any of the stateful data for the user authorization into the memory. The servers become very, they don't have any overhead because of this nature. And then your servers computing power is utilized for actual job of the service itself. It doesn't have to deal with the overhead of storing this data, right? And then we also spoke about how easy it is to scale with a pivotal platform, right? That's what they've been saying for the last few days, right? From that, if you have a large volume or load coming in at any given moment, because of the auto-scaling nature of the platforms with cloud, now your services, because of being stateless, it can expand, upscale, downscale based on the load at a real-time dynamically. Your services are now adapted to that, right? So if a node goes down in your cluster of servers, the application is still serving back the data to your consumers, and the resiliency of the platform is very much improved because of the stateless nature. So we briefly touched upon that gateway, more used at how it is used at the public-facing layer or the global security layer. We also can expand on this gateway pattern using Spring Cloud Gateway, even IDP, along with it, to even the domain services, to use it as an aggregation layer for when you have multiple services behind or multiple data sources behind, right? You can have a gateway in between to take care of orchestrating it, aggregating it, and sending back the data to your clients. So there is also a key use case we had where one of our API, which was public-facing, over a period of time, we had one type of legacy authentication mechanism, but then over a period of time, we wanted to support OAuth-based authentication mechanism. Now, with implementing this pattern, the gateway, which was at the front-facing, took care of dealing with all those different types of authentication mechanism and working with IDP. Now, IDP generated a standard JWT token, and your microservices just have to deal with that standard token. Even in future, if a newer type of token that mechanism gets implemented, all that is behind the gateway itself. It's all abstracted at that layer. When it comes to your microservices, it still deals with JWT. It's very simple. It's faster that way. You don't have to worry about changing your microservices. You kind of maintaining that abstraction at that layer. So the other key factor is monolith strangling, right? Now, in our case, and I think in most of the organization cases, they would have started with the monolith, and then at some point in time, they want to build into smaller micro-domain data services or microservices at that layer. And then because of implementing this gateway, now gateway takes care of routing, and it knows whether it's to route to the monolith or when you break down into the smaller microservices, at the gateway layer, it will start routing to the microservices. So because of this, your end clients are not impacted, and you have a way to leverage some of the canary and other concepts of cloud platform to faster deliver to market, leverage all the tech agility principles, test drive, and all that stuff we can achieve with this gateway in picture. So there are also a couple of key developer-oriented principles. So one of them is separation of concern. Now, since your gateway takes care of all the cross-cutting functionalities, and your IDP takes care of authentication, authorization, and your microservices just have to deal with the business logic. They don't have to deal with any of the logic for security and all the cross-cutting needs. So this becomes kind of a principle which developers like for separation of concern. This helps with that. There's also another one where it's called DRY, don't repeat yourself. So wherein if we didn't implement this way, you have to end up writing the code to write authentication layers and then write all the libraries and all the things we spoke about to code all that. Even you might have to end up calling additional services to get the authorization data. So all those duplication of code, now we no longer have to do it. You all deal with the JWT token, and that simplifies the architecture and security for your application. So end of it, to summarize all this, by implementing this pattern, it really helped us to simplify our architecture, help with all the monolith strangling and building all the microservices and putting it in the cloud platform. It really helped us standardize our APIs for the clients. It helped improve our performance and resiliency of the entire architecture for TD Ameritrade. So that's pretty much it. Thanks, guys. Any questions?
So maybe I understand this part. So basically your client is sending the identity token, not the authorization token, right? And the authorization token is acquired essentially dynamically on each request.
Yes.
So why you made this decision instead of going more like typical auth approach where the client would actually have authorization?
So the client gets the initial OAuth token, which is basically still OAuth token itself, but it's a little opaque token. It doesn't have all the authorization data in it.
Yeah,
so
identity provider,
yes.
Identity, but not.
So yes, because when the client calls your microservices, the request could be, for example, order, or it could be alerts. It could be any other request. When the request comes in, you're building a brand new JWT token. At the time, you are factoring in the scope, and then just the authorization roles that needs for that request. The initial token, you send it over. For the initial authentication, that's just an opaque token. You can't put in all the scopes and all the data in it. That's why that token is a little bit opaque token. And then the second token we create is a smarter token. That's why we are restricting and securing in this way. Yes. One of you. Yeah. Got it. So the question is, just because you have a gateway and the gateway again talks to another IDP, it's additional hop on the network, is there any latency concerns? So behind the IDP, right, obviously we have to create, for every request, you have to create a new JWT token because of the nature of the request URI could be different. And then behind IDP, right, it could have a mechanism for caching it in a store, right? That's all behind IDP. So that way, you're not, every time you have a request for a particular user, you still can, for that period of expiration, you could still cache it. You don't have to go and get all the roles and response details and package it again. Yes, yes, it will be clustered, so it is all stateless. The IDP is reactive to, it could be reactive to, it could be stateless. It could be distributed as well, where you store this in a, like a centralized storage as well at that time. But then it can be scaled across, for sure. Yes.
For the second token, so that's one token is basically that you are getting access to every microservice. So if different microservices may have different set of permissions or different access levels.
Correct.
So how does it handle that?
So based on your URI, right, when the IDP creates, it looks at the audience, target audience, and part of the OAuth token spec, you have an attribute for subject token type audience, and then in the JWT token by itself, you're adding the scope and you're adding the roles just for that URI. And that's how we are making sure that only the target audience, who is the intended audience, when they receive this request, only that audience will be able to accept the token. And also you are signing with a private key in the IDP, and only the microservices have the public key to decrypt it, right? So it's kind of secured at that way as well. Yes. Okay, so that's a good point. The question is, what if your public key changes over a period of time? You have to update, if you have 100 microservices, do you have to go and update all your microservices to update the public? So we haven't shown on the diagram. The way we were thinking to implement that is, your microservices, because it's no longer have to talk to gateway, your microservice can talk to IDP though. In a way, whenever you have a mechanism to reload or refresh and check that if there is a new public key, it can get it from IDP and then locally update its local memory or whatever, wherever it is keeping the public key data. So that way now you update your So you also have the private key and the public key endpoint on the IDP that the microservice can real-time use it to fetch the public key, and they don't have to update any code or config or restart any server. It's all on the runtime. That's a JWKS standard. So yes, he's pointed out. Thanks. Yes.
So I have two questions. So the first one is like, what about the auth and auth for internal applications? Because to reduce the
Yes.
sector.
Yes. So his question is, now you have protected the app services layer, but now how about from app services to your data domain services? How do you secure it? Is that correct? So yes. So one of the points we pointed out is even at that layer, it could obtain a new token from the IDP. The app services can obtain a new token from the IDP, and your data domain service should also do the same way of validating the token, new token, and authorizing it. So earlier days, if you see, the services might not even be protected. That was a thing we spoke about also. Because you're relying on your network, you might not even have a security for your internal services. But the way we are showed is have a token being passed from your app services to your data domain services, and have them talk to IDP as well if need to for generating a new token. Sure.
How about canary? Because now how does it fit into the canary? Because we have the routing built in.
Yes. Yes. So canary, so basically you could route your traffic. So when you're strangling your monolith and microservices, it might be re-implementing the same functionality feature. You could have a way of, so canary can apply in two ways. One, for strangling you can use it where you have the same setup endpoint request. You could canary some of your load to your microservices, or even canary can work in where you have new update to your microservices, right? You can always say keep both older and new and then route it some other traffic and slowly while it's coming up or while it's up, so you're getting 100% uptime, and also you're slowly moving your traffic into the newer version of your service.
So the question is more like the router is also playing the role, and now gateway kind of is the router as well. So very.
So in this case, the gateway is the one who's routing to your microservices. So gateway level, you will add the canarying logic.
But what about traffic to the gateway? Like if you have,
If
you're doing deploying the gateway itself.
Oh.
Okay. Chris, you want to take it?
You're doing a good job. I'll let you do it.
So gateway, you're not bringing it down, right? So your routes, maybe, yes, you're right. So that time, only when you're updating the routes on the gateway, so you might have to restart, you're right. That time you have to do blue-green on the gateway, and then you have to apply the canarying on top of that. So it will be a little complex where you have changes to both gateway as well as your microservices. But then you can always roll in separately. Maybe first roll in only the microservices, and then test that separately, and then enable gateway routing logic later on. So you can do it in 2 releases or 2 ways, right? You don't have to upfront push everything at once. So I don't know if I answered your question or makes sense. Okay? All right, thank you. Yes, Pat.
For inter-service communication, I understand your service will talk to IDP and get JWT token back to talk another service.
Correct.
But you also need discovery. Did you use Eureka or did you use Stateless for the inter-service communication?
So we didn't use, so in our case, we didn't use service discovery at all, but you could use that if you want to understand how it was. We had a NetScaler, we had the Go route routing as well, right, with the PCF. But yeah, we can implement service registry, service discovery.
But will it be like more layer for the like inter-service communication, like it goes to the like public string cloud gateway and come back just like some external?
No, it will not. So your app services, when it talks to your data services, it will directly go to IDP. It won't go through gateway. So
Not for the data service, like if we connect to that, like I would have 5 microservices and I want to like put inter-service communications, right? But that means I don't want to talk directly using endpoints. I need some discovery. Now, as we are already using Spring Cloud Gateway, which also has like discovery, right? I mean, my question is like, is it okay to use that or?
So there was one other slide. We had a slide where we said that we can expand on this at any level, right? At any layer. I don't know if we can go back to this.
Just select on it.
Yeah. So this is a slide we had, right? So you could have this gateway implemented even for your aggregations, your routing, so the gateway is kind of has a broader cross-cutting functionalities you can use for any of those cross-cutting. Could You could leverage that for not just the front-facing web apps gateway. So you can also use that for aggregation or even domain services. It depends on your needs. So we had a case where we had a gateway at aggregation layer where we had multiple data sources, and then they had to do some orchestration on top of it. So we had a gateway for that. So you could apply there. Yes. So we did a thorough benchmarking on that. I don't know if you guys had attended Stefan and Violeta's session. So they had also benchmarking on how WebFlex versus WebMVC performance was, and especially how Spring Cloud Gateway worked. So we did a similar benchmarking with Spring Cloud Gateway with other competitors like Zool2 and other products too, right? So we realized the throughput and performance and number of requests and the timeouts, they were much better with Spring Cloud Gateway. And even when you have a direct access where it's blocking versus where you have a Spring Cloud Gateway where it is non-blocking, the requests it served were a little bit better when you have a huge load, and it makes sense. I think, yeah. So I think we will wrap up. If anybody has questions, you guys can talk to us here. All right.
Thank you.
Thanks.